Today's lesson is on tolerances. So we've looked at accuracy and precision. Now we're going to look at tolerance, which means you should be as accurate as possible when measuring and making your measurements precise. But when you are actually manufacturing stuff or measuring a range of measurements are often acceptable. The range of acceptable dimensions is called the tolerance. The concept of tolerance is important because when you install and assemble parts, they must fit together, work properly, and perhaps look right. Here are some examples of things that you would be looking at when you're dealing with tolerance. Two parts of a hinge must fit together and can't slide against each other or because otherwise the door will tilt. A kitchen cabinet installation must leave room for the kitchen door to open without obstruction. So there has to be some tolerance in there. The door could be a little bit bigger, a little bit smaller, but not too big, otherwise it's going to hit the counter. A crushed ore screen at a mine must allow only pieces smaller than a particular size to pass through, otherwise equipment could jam up or get broken. So small variances do occur in manufacturing processes. When you're making bolts and nuts, for example, they're not always going to be exactly, perfectly the same size, but they have to be within a limit of tolerance. Okay? There could be a range that's acceptable, but then if they get too big or too small, they're not going to be usable. The nominal value is the target range. So we want to aim for, say, a 1 centimeter bolt. It's the range that we want to hit. But then there is also a range of tolerance. So what is the minimum value that would be acceptable and what's the maximum value that would be acceptable? The nominal value is usually halfway in between. So we could be 1 centimeter plus or minus 0.5, if that's what was acceptable. Okay? So your nominal value indicates that the value that's being aimed for, but the amount of difference above and below this value can be accepted. The manufacturing tolerance is different between the maximum acceptable dimensions and the minimal accepted dimensions. They can be written in several different ways. Maximum value over minimum value, written above each other. Nominal value plus half the tolerance, or you could write minimum value plus the tolerance or maximum value minus the tolerance. Tolerance is not an uncertainty, but rather the acceptable range of a given measurement. Lana works as a mechanical designer in Edmonton, Alberta. She specifies the dimensions on a machining drawing that has a tolerance of 0.02 of an inch and a nominal value of 0.5 of an inch. If the nominal value is the midpoint of the tolerance range, how can the designer write the dimensions so the machinist knows the acceptable range? So the nominal value is what is going to be the target measurement, and then the tolerance in between the high and the low range is going to be 0.02. So we need to take that and divide it by 2 because our target range could be plus 0.01 of an inch, or it could be minus it. So you could be higher by 0.01 or you could be lower by 0.01. Okay, that's one way to write it. Second way to write it, we could actually write it as values. So this could be 0.015 of an inch or 0.490 of an inch. This would be the max value and this would be the min value. Okay? The last two ways to write it would be the min value plus the tolerance. Oops, sorry, got the 0 in the wrong spot. Then of course minus 0 because this is the lowest value it could be. The last way to write it is with the max value and you would add, of course, 0 because that's the maximum it could be. You're not going to get any bigger, but you could be up to 0.0 2 of an inch smaller. The one that's most common is the first one, the nominal value plus or minus half the tolerance, or this one you will also see the max and the min. Notice that if I subtracted the max and the min, I would get back the tolerance. The difference between the highest number and the lowest number should be how much the tolerance is. Okay, another dimension on the drawing is specified as follows. Express it as the nominal value plus or minus half the tolerance. So the nominal value is halfway between the high and the low. How do you find halfway between? Well, the nominal value, it's like finding the average or the mean. You take the two measurements, the biggest measurement and the smallest measurement, add them together, and divide by 2. So your nominal value in this case will be 0.240 of an inch. Okay, so that's your nominal value. Your tolerance is the difference between these two numbers. Okay, the space or the tolerance that you're going to have in between the two numbers. How much bigger or smaller could they be? So your tolerance is your maximum minus your minimum. Okay, and we always use half the tolerance when we write it in this form, so I'm just going to divide it by 2. So the max is 0.250 minus 0.230 divided by 2. Let's not do that way. I'm not going to divide by 2 because the tolerance is actually the difference between those two, which is 0.020. Okay, and then you are actually going to take half the tolerance. So my nominal value to write this out is 0.240 plus or minus half of the tolerance. So I would divide that in half first to write the final answer of 0.010. So from here, this is the middle value, the one you're shooting for. It could be bigger than this measurement by 0.01 of an inch, or it could be smaller by, again, 0.01 of an inch. In example 2, we have a home renovating business, and we are trying to cut out electrical boxes, so for outlets. What is the size and tolerance of the hole? Well, this dimension is how big the space is for the plug, and this is how much space there is for the back box. Okay, so the tolerance is the difference between the max and the min value. So the maximum value could be 2 3/4 inch. The min value is 2 inches. So the tolerance is actually the difference between those two. So you would subtract them. So my tolerance is 3/4 of an inch. Okay, the acceptable range. To get the plus minus range, it's half the tolerance. So we need 3/4 of an inch times a half. When we multiply fractions, you multiply straight across, so you have 3/8 of an inch is how much your range could be. So the nominal value is going to be the minimum value plus half the tolerance is how big the hole should be cut. Okay, so the minimum value is 2 inches. Plus the tolerance is the width of the hole. So the width of the hole is 2 3/8 of an inch, and you could be out plus or minus 3/8 of an inch. Okay, so the 2 3/8 of an inch is the nominal value, the target value, which is halfway between the max and the min. The other way to find out the nominal value, which we did in the previous example, So the nominal value is the middle value. You could take 2 3/4 of an inch plus 2 inches, the max and plus the min, and divide it by 2. And you would have got 2 3/8 of an inch. So your nominal value, either way, is 2 3/8 of an inch. In this case, would it be better to make the hole smaller or bigger? Well, it would be better to make the hole smaller. If you are cutting something, it's always bigger to make it a little smaller, and then if it doesn't fit, you can always cut it a little more. If you cut it too big, you can't fix it. You'd have to replace the whole gyprock. Okay, on the plug-in, you'll notice that on top of this plug-in, if you take the screws out and take a faceplate off of your plug-in switch, there's actually a plate that covers to make sure that you don't see any holes. But if you actually cut the hole too big, you're going to see space outside the cover plate, and you can't fix that. You'd have to replace the whole gyprock or the wall. Okay, what might the answer to B be reflected in the way the tolerance is expressed? Well, it might be more practical to write the dimensions as follows. The width you want is 2 inches plus 3/4 of an inch, but you don't want to be any smaller than that. And the height of your plate, you want to be 3 inches plus 1.5 inches, but not any smaller than that, or it'd be too tight. This emphasizes much better that the hole can be smaller rather than bigger. So you want it to be 2, maybe a little bit bigger, up to 2 3/4 of an inch, but you don't want it bigger than that. All right, so build your skills, page 93 to 94, as well as 96. I'd like you to work on that and correct them. Make sure you can do them well. Before you move on to the practice your skills, page 102 to 104, questions 1 to 4. There are 2 extra questions here, the additional questions that are a little more challenging, more word problem type. There will be questions on the assessment that look like these kind of questions, so please practice these types of questions, don't skip them. They are attached, okay, they're going to be here right after that page with the assignment numbers, and as well as here. There's going to be the answers on the next page. When you've completed all of those assignments, I'd like you to complete the chapter test that's in your workbook, page 105 to 108 as a review, questions 1 to 12. Bring those in for checking and request an assessment. You're ready to do the first test.